Assignment method is a special class of linear programming models that assign tasks or jobs to resources. Objective is to minimize cost or time, and only one job or worker is assigned to one machine or project. So you see, the assignment method can be used either to minimize the cost or minimize the time. To do the assignment method, we have to follow the rules. In the first rule, we have to evaluate the row and column by looking at the lowest cost for each row and column. Second, we will try to draw the line by looking at the number of zeros in the first step. And there is rule. If the number of lines equals either the number of our rows or number of columns, we can go directly to proceed to step 4, which is assignment step. Otherwise, we can go to step 3. The step 3 is we subtract the smallest number not covered by a line from all other uncovered numbers, and then we add the same numbers to any number at the intersections of two lines, and then we can go and return to step number 2. Number 4 is the last step, where we do the optimal assignments and at 0 location in the table. We can select one, draw lines through the row and column involved, and continue to the next assignment. This rules is very easy and can be understood if we do it by example. In this example, this is a simplified problem where we build a table of cost or time associated with particular assignments. We have three jobs, 34, S66, and T50. And then we have typesetters A, B, and C with the cost associated. Let's say if A have to do the R34, the cost will be 11. If B have to do the R34, the cost will be 14. If C have to do the R34, the cost will be $6, and so on and so forth. So as I told you, if we do the example, we will understand easier. So the first rule, if we want to do the assignment sample, we have to evaluate the row, each row and each column. And how do we evaluate each row and each column? You have to subtract all cells in each row and each column by looking at the lowest cost. So you see we have 3 rows, and then we will evaluate each cells by looking first at the rows. The first rows, which is R34, we see the cost 11, 14, and then 6. The lowest amongst the 3 is 6, which means that we have to subtract all the cells by 6. 11 subtracted by 6 is 5. 14 will be subtracted by 6, which is 8. And then 6 subtracted by 6, which is 0. And then we go to the next rows. We're trying to look at the lowest cost from these 3 numbers, and the lowest cost is $8. And then we will subtract all the number in the second rows by looking at the $8, $10, and 11. And 8 will be subtracted by 8, and then 10 will be subtracted by 8, and then 11 will be subtracted by 8. 8 subtracted by 8, which is 0, and then 10 subtracted by 8, which is 2, and then 11 subtracted by 8, which is 3. And then we go to the next rows, which is 9, 12, and 7. And then the lowest amongst the 3 is 7, so we subtract all the cells in these rows by 7. So 9 subtract by 7, which is 2, and then 12 will be subtracted by 7, which is 5, and then 7 will be subtracted by 7, which is 0. Now we do the first step by evaluating the rows. Now we will evaluate the columns because that's the necessity in the first step. In the way to evaluate the columns, we now evaluate this table, which is the evaluated rows table. we do not evaluate this original table if we want to see how the columns should change. So now we review this table to see the column sections. First, we evaluate the A column, which is 5, 0, and 2, and the lowest is 0 amongst the three. So we subtracted all the cells in the column A by 0. So 5 subtracted by 0, which is 5, 0 subtracted by 0, which is 0, and 2 subtracted by 0, which is 2. And then now we go to B column, and then we look at the numbers, which one is the lowest, which is 2. So 8 subtracted by 2, which is 6, and then 2 subtracted by 2, which is 0, and then 5 subtracted by 2, which is 3. Now we go to the next column. So C column, we see that there are two zero number. The important thing is that we can identify the lowest number here. So the lowest number is 0. In this case, we subtract all the number in the C column cells by 0. 0 subtract by 0 will be 0, and then 3 subtracted by 0 will be 3, and then 0 subtracts by 0 will be 0. So now we have done the first step. We have evaluated each rows, we have evaluated each column. The next step is that we try to cover all zeros. So you see we have 1, 2, 3, 4 zeros, and then we'll try to go to the step 2. Just to remind you, we will go to the next step, which is the second step. We will try to draw the minimum number of vertical and horizontal lines necessary to cover all the zeros in the table. So you have to remember that we only need as minimum as possible. So it doesn't mean that if we can make line and then we can make as much as we want, but we will try to cover all the zeros, but in the minimum way. So let's say if we make one line and it's already possible to cover all the zeros, so we stop to make one line. If we need two lines, it means that we only make two lines, and so on and so forth. So you see, if the number of lines equals either the number of rows or number of the columns, we can go directly to step 4, which is assignment step. But if it is not equal either to the number of rows or number of column, we must go to step 3. So you see here we have 0, 0, 0, 0 in these tables, and then we will try to make lines. We can make lines, for example, from 5 to 0, one line. We can go to make lines in S66 like one line, and then we go to the T50 from 2 to 0, we can make 3 lines. But is it the minimum line to cover all the zeros? Let's say we can make lines from 502, 603, and 030, but is it the minimum line? So in this case, the minimum line to cover all the number is by dragging the line from 003, and from 030 we can cover all the zero by only making two lines. So in this example, we have two lines. In S66, we can make the line here and we can make the line here. And then we have to count the number of the lines. And then we have to count the number of the rows or the number of our column. In this case, our column number is 3 columns, or our rows number is 3 rows. It means that to know that our solution is optimal, we have to make sure that the number of our lines is already equals to the number of our rows or our number of columns, as the rule stated in number 2. So as you see in the second step, if the number of lines equals either the number of rows or number of columns, we can go to step 4, which is not possible in this case because our solution is not optimal. In this case, we have to go to number 3. Step number 3 is we subtract the smallest number not covered by a line from all other uncovered numbers. And then we add the same number to any number at the intersections of two lines. And then we return to step 2. So you see, based on the step 3, we have to see the uncovered number and looking at the lowest number. So the uncovered number is 5, 6, 2, and 3. And the lowest number is 2. And then we have to subtract all of these cells, the uncovered number, by 2 since it is the lowest number. So 5 subtracted by 2, which is 3. 6 subtracted by 2, which is 4. 2 subtracted by 2, which is 0. And then 3 subtracted by 2, which is 1. And then in the step number 3, we also need and we must add the same number, which is the lowest number, to the intersections. In the intersections, we have 3 here. So 3 will be added by 2, which is 5. So now we have this new table, and then we have 0, 0, 0, 0, 0. We must return to the step number 2, where we try to draw the minimum line to cover all these zeros. In this case, we can try to make 1 line, 2 line, and 3 line. Is it the minimum number? Or can we make just 2 line and we can cover all the zeros? Let's say make 1 line and 2 lines. We cannot stop there. We have to make at least 3 line, which is the signal for us that the solution is already optimal. So in this case, we try to make lines, 1 line, 2 lines, and 3 lines, and we already cover all the zeros in the tables. So because 3 lines are needed, why and how do we know that we only need 3 lines? By looking at the number of our rows or number of our column. So we try to see that we have 3 rows, and then we see that 3 lines, and it means that the solution is already optimal. And based on the step in number 2, if our line is already equal to the number of our column or number of our rows, it means that we can go to step number 4. We can do assignment step. So in the assignment step, we have to look at the 0 location in the table, and then we can select one, which means that which one should do which job, which is the case, the optimal assignment. So in this case, we can see that A, B, and C and the job are 34, S66, and T50. You see the location of 0 here, location of 0 here, location of 0 here, and location of 0 here, and location of 0 here. We try to choose. You can either make this T50 first, S66 first, or 34 first. But we have to make the feasible location first. Let's say R34. We want to put the R34 whether in C, B, or A. But in this case, the optimal solution that we put R34 in C. As 66, in this case, it can be put in A or B, but in this case, let's say we put S66 in A. It means that T50 will not have other locations. So we choose B in this case because we do not have other options. And then in the case of T50, we choose A because that's the only possible locations. Actually, we can put it in C because there is 0 here. But the thing is that we already put R34 in C. So the only feasible locations to put 350 is to put in the A, and it is the optimal solutions. So now we have R34 assigned to C, S66 assigned to B, and T50 assigned to A. Now if we want to know the original cost, so we see the original table. So in the original table we know as if for example A have to do the R34, the cost will be 11, B the cost will be 14, and so on and so forth. And now we know that R34 will be done by C and the cost will be $6. And then we know that S66 will be done by the B, so the cost will be $10. And then T50 will be done by A and the cost will be $9. So we know now that the minimum cost is $6 plus $10 plus $9. So that will be the way how to do the assignment method.